In this module, you will learn about our continuously changing dynamic Earth and how it was formed. The Earth that we see today is the product of millions of years of geological change. How did the Earth evolve into the planet that we inhabit today? Were all the continents always in the positions that they are currently located? Scientists have been working for decades to find answers to these questions. The most popularly accepted theory on this came in 1915 from Alfred Wegener, a German meteorologist. He proved that millions of years ago, all the continents were joined in a supercontinent, which he called Pangaea. Pangaea is a Greek word that means all lands. So, what happened to Pangaea? Wegener said that due to some internal pressures and the movements of plates on the Earth's surface, Pangaea broke into pieces. Those pieces of land started drifting away from each other. The big land masses became continents. Water collected between these land masses to form the oceans as we know them today. Here is an interesting fact that substantiates this story. If you examine the shapes of the continents closely, you'll notice that the edge of the west coast of Africa complements the shape of the east coast of South America. Just like these were two pieces of a huge jigsaw puzzle. The theory of the splitting of the big landmass into 7 big continents is known as the theory of continental drift. But what caused the continental drift? In other words, why did the continents break up and drift away from each other? Another theory, the theory of plate tectonics, can answer this question. Let's look at the basis of this theory. The lithosphere consists of a number of plates called the lithospheric plates or the tectonic plates. The word tectonics comes from the Greek root to build. A plate, in geological terms, is a large, rigid slab of solid rock moving on molten magma on the Earth's surface. The circular movement of the molten magma inside the Earth causes the tectonic plates to move slowly. This movement can be as little as a few millimeters each year. However, slowly, this movement causes changes on the surface of the Earth. Here is an activity to illustrate how molten magma moves inside the Earth. Fill half a beaker of water and put the beaker on a tripod burner. As the water starts boiling, put a crumpled paper in it. As you can see, for some time, the paper floats upwards along the warm upper layer of the water. However, after a while, the crumpled piece of paper starts sinking with the cooler part of the water. The movement of the mantle inside the Earth's surface follows a similar pattern. This leads to the movements of the tectonic plates and changes on the surface of the Earth. The Earth's movements can be categorized into two types, based on the forces that initiate these movements. Some movements are caused by forces acting in the interior of the Earth. These forces are called endogenic forces, and the movements thus caused are called endogenic movements. On the other hand, forces that work on the surface of the Earth are called exogenic forces. The movements that result from these forces are called exogenic movements. The Earth's outermost layer, or the continents, are moving under the influence of endogenic forces generated within the Earth due to the tremendous heat in the mantle. These forces can be sudden forces that may result in natural disasters, such as earthquakes, eruptions of volcanoes, and landslides. Endogenic forces can also take the form of diastrophic forces that act slowly over a period of time. Diastrophic forces refer to forces generated by the movement of the solid material of the Earth's crust. Diastrophic forces result in the bending or breaking of rocks. The bending and breaking of rocks creates mountain systems like the Himalayas and deep valleys and trenches like the Mariana Trench. Endogenic movements can be vertical or horizontal. Vertical movements cause uplift or sinking of the Earth's crust. When the Earth sinks, valleys are formed. When the Earth is lifted up, mountains are formed. As mentioned earlier, apart from endogenic forces, there are exogenic forces that act on the Earth's surface. Exogenic forces can take the form of weathering, erosion, and deposition. Weathering is the breaking of rocks on the Earth's surface by different agents. These agents could be rivers, wind, sea waves, and even ice in the form of glaciers. Erosion occurs when the same agents carry away the broken rocks to other places. Finally, let's look at the process that leads to the rebuilding of the Earth's surface. Deposition. Deposition is also caused by natural agents like wind, water, and glaciers. Sand dunes in deserts are the most common example of deposition. A sand dune is formed when wind blows sand away from one place and deposits its load in another place. You will learn more about the results of various endogenic and exogenic forces and movements in the next modules. Meanwhile, let's quickly recap what we've covered so far. In this module, you learned that Alfred Wegener's theory of continental drift proved that millions of years ago, all the continents were joined in a supercontinent which he called Pangaea. Due to the movements of lithospheric plates, the supercontinent broke into large land masses that drifted away. The big land masses became continents, and water collected between the land masses to form oceans. The lithosphere consists of a number of plates called the lithospheric plates or the tectonic plates. The Earth's movements can be endogenic or exogenic. Endogenic movements may be sudden or diastrophic. Exogenic forces are external forces and include weathering, erosion, and deposition.